Hi, this is Praveen. Tamil Sign Language Interpretation is my final project. Talking about the problem background, this problem was chosen as there's an increase in people with hearing difficulties. So a technology where others could understand what people with hearing difficulties are trying to convey would ease the communication barrier that is between the normal people and the people with hearing difficulties. And this particular problem had so many solutions. So I was able to add something advanced to it and improve it in a technology way. Most of the technologies found was for English and few other languages, but there wasn't a proper technology for Tamil where it actually helps the people with hearing difficulties to convey like I have mentioned in the slide. In Sri Lanka, there is quite a number of people with hearing difficulties, and technology like this would ease the communication barrier between them, and it is becoming difficult for the normal people to understand their gestures or what they're trying to convey. Also, people who can't speak and hear feel isolated, as majority of the normal people who don't know the sign language would understand them, and normal people wouldn't try to learn the sign language as they can speak and hear well. In the future, the number of physically impaired people are going to rise. Knowing that many methods have been proposed and few of them have been implemented using technologies like machine learning techniques, but people with hearing difficulties will have to use interpreters to communicate to the normal people. They had to always have an intermediate to do the communications. So it is in a state where people who are physically people who are with hearing difficulties will have to use interpreters or ask something from a person, as they feel normal people wouldn't understand what they're trying to convey. So this is the problem background. To talk about the research gap, first of all, like mentioned in the slide, there are more technologies related to sign language and in different languages and in different countries, but when it comes to Tamil, there is no much technologies that have been made or created, and the ones that are created for Tamil aren't that much accurate or like working properly, and the sign language, like the use of signs, like the limitations they have used is like 31 alphabets, where where the images have to be captured in a different way so that the detection can be done, and so many other conditions as well. And the data and regarding the data, since there is no data set available for Tamil, and there is no data set available for Tamil words, and the very few data sets which are available are very like unclear or unable to use. So this is the gap where there is no data set, and only 31 alphabets are being mostly used in most of the technology that have been created. 31 alphabets have been used, and each have been like the system just detects each alphabet and gives the output like what this alphabet is. And the images, of course, taken in different angles would not be detected. So there's a particular angle which has to be taken in, and that is how the picture has been captured in the previous models and input, and the output has been taken. And so this is the research gap. The solution proposed for it is mainly like in this solution there will be like two signs, I mean two, like both static and dynamic signs will be used, but majority of it will be static and few of dynamic signs will be used in this. And 20 signs which are equivalent 20 words will be used in this project, and 15 sentences will be interpreted accordingly. And since there is no much data set available for this particular Tamil sign language, I had to come up with my own data set, and the data set of 1500 images of 20 signs have been made by myself, and that will be used to train and test the model. So about the process, so the person with the hearing difficulty will either perform and capture a video, or input an image to the system, and the system will be, in case if it is an image, it will be directly sent to the object detection model, or if it is a video, the video will be broken down into frames of images and it will be sent to the object detection model. Once the signs are detected, the particular words will be sent, the relevant sign words will be sent to the NLP model to do the sentence interpretations. Once the sentence is interpreted, it will be displayed to the user. So this is how the process works. So like I mentioned earlier, so this is how the process works, and this is a rich picture diagram on like how the features and how it works. So usually the user performs the signs, and then either by taking pictures or like videos. In case if a video is taken, then the video is broken down into frames of images, and then it is sent to the object detection model. Else if images are uploaded, then the images will be directly sent to the object detection model. So once it has been sent to the object detection model, the object detection model will detect the gestures and gives the words as the output. So once the word is given as the output, the words are sent to the NLP model to do the sentence interpretation. And once the sentence interpretation is done, it is sent to the it is displayed on the web application for the user to see. So this is how the system works. Next, talking about the future plan. In the futures, if the developers are interested in this particular domain, they could enhance the system by adding more gestures to it, and interpreting more sentences, as this particular system is limited to only 20 signs and 15 sentences. Also, additionally, they can add multiple languages of translation, where in case a signer performs the sign, and in this particular system only Tamil interpretation is given, so the sentence output will be in Tamil. So what in future they can do is they could translate the Tamil sentence into Sinhala or English, give them options where they would like to choose, and so regardless of who they are talking to, they can easily translate to that particular language and tell them, okay, this is what I'm trying to say. And also many validations can be done in the future system. And also this is a web application, so the developer can add a mobile system where a mobile application can be made for the sign language system. So where it is like really portable, so they can carry it every time when they go out or wherever they meet, or they can easily translate, convey whatever they're trying to say. So that would ease their life even more. So these are the future enhancement and plans. To talk about the initial implementation that I have done, so so first it is about first thing that I did was the data preparation. So these are the libraries that I have imported for this particular set of code to be run, the required libraries. So here the dataset path and the annotations path have been fixed. So before the data preparation, I had to draw the bounding boxes for 1500 images, and that was done before the data preparation was done. And the bounding boxes output an XML file, and all those XML files are stored in this annotations folder. And here the file function is to retrieve the name of the file name, and here the train file function will be getting all these variables such as file name, the coordinates, and the class from the XML file that is in the annotations folder. And here the function is run, so giving the path. Here this is how it has been printed, and this is how it will look, the class and the coordinates and the file name. Then the file has been converted to a CSV. Here the final thing where an annotation text file will be produced, which contains the coordinates and the relevant image URL along with the class name and the file name. So this will be used during the final implementation while training. This is about the data preparation. So moving on to the implementation part. After researching so many articles and papers, I decided to use faster RCNN for sign language detection. So what is faster RCNN? Faster RCNN is a deep convolutional network used for object detection that appears to the user as a single end-to-end unified network. The network can accurately and quickly predict the locations of different objects. So faster RCNN is basically the extended version of fast RCNN. So faster RCNN consists of two topics, the main topics like RPN, and that is region proposal network, and fast RCNN. So usually RPN is used for generating region proposals, and fast RCNN is used for detecting objects in the proposed regions. So this is the config. So talking about the config class, so this contains all the parameters that were used in this process. To start off with, the network that was used in this is the VGG network, and here the anchor box scales are done, where in case if the size of the image reduces, then the anchor box will scale it accordingly. um, and here the number of ROIs used are mentioned, and the RPN minimum overlap and maximum overlap are assigned. So this is about the configuration class. Next, moving on to the ROI pooling. So usually what happens in ROI is ROI pooling extracts equal length feature vectors from all proposals in the same image. So that is basically what ROI pooling does. And also it splits each region proposal into a grid, and then max pooling operation is done. So what is max pooling operation is like where the higher value is uh, returned, like so the difference between the ROI and the region proposal is where in region proposal it has to have in case if there are 128 regions proposals, 128 images are required to get that. But when ROI does the region proposal, what it does is it uh, only two images are taken, and within two images each image would give 64 region proposals. So the time taken to figure out the region proposals are reduced in ROI. And also ROI was introduced in fast RCNN, and that is basically about ROI pooling. And here the ROI pooling class and the method definitions are given here, and it is called later in different classes to implement the process. Next, moving on to the RPN layer. So basically RPN layer is region proposed network. So what that network is, like I mentioned earlier, it is used to detect the region proposals. What makes RPN better in terms when compared to ROI is it guides the fast RCNN, like where to look for objects in the image. So it basically tells you like this is where the object is. So and in the image. So that is the main process of the RPN. And for every region proposal, a fixed length feature is extracted using ROI. So usually how the process works is first the RPN layer gives the region proposals, detects the region proposals, and once the region proposal is detected, it is sent to the ROI pooling layer, where, like I said earlier, the ROI pooling layer would do the grid thing, where the highest value is returned. So this makes the system speed up. So this is how the system works. And next, talking about once the object detection is done, it has to be the word has to be sent to the NLP to detect and map the actual sentence, the Tamil sentence, and all the words, and give the Tamil sentence as the output. So this is where the NLP model is being trained and created. So starting off, tokenization is done. So tokenization is where the sentences array is changed into a 2D array, where each word in an array index has been separated into different indexes in one array. So that is done here. And then here the each separated indexes of words are tagged. So here so here there are 14 tags in this, as there are 15 sentences. So this is where the tagging happens. And then moving on to the Doc2Vec, this is where the model is uh, where it is trained and the model is saved. So Doc2Vec is used to train and to save the model. So here it gives the output of each and individual words so that is available in the given 15 sentences. So here the model is created. So this is about the implementation of the data science part. Next we move on to the back end and the front end. So talking about the front end and the back end. So front end was done using HTML, CSS and JavaScript, and the backend was done using the Flask API. So the backend contains three Python files, that is capture images, server.py and test deploy. So server.py is where the API calls happen, the request and the responses. So and here is where once the message is got from the object detection model, it is sent into this, and the definition from the test deploy class has been called here to detect the gesture. And once the gesture is detected, then the word will be given, the words will be given as the output. So once the words are given as the output, the words are sent into the conversion part, where the words are converted to Tamil. And once the words are converted to Tamil, the Tamil words will be then sent to the matching part, where the tagged process the highly matching tag, that is what happens in the NLP model. So once the Tamil words are sent to the NLP model, it automatically finds out the most suitable tagged sentence for it, and gives the output for the particular for the relevant images or the video uploaded. So here is the index method, where all the requests and the responses are called, and here the config class is also called. In the captures.py, the conversion class, here is where the words are converted to Tamil, and get video frame. So usually once you get the video, the video has to be broken down into frames of images before it goes to the object detection model. So in this method, the video is broken down into images. And going to test deploy. This particular method, sign detection. So here it gets into arguments, the image save path and the length. So so inside this method, the model is loaded, and once the model is loaded, it will be once the model is loaded, it will send in the images to do the detection. And once the detection is done, it will be sent, like I mentioned earlier, the process happens. It will be sent to the conversion method, and then it will be converted to Tamil, and from there it will be sent to the sentence prediction definition. Here the NLP Dr. Vic model is loaded. Here is where the words are transformed into the tagged sentence, and the highest matching sentence will be given as the output. So that is what happens in the backend. In the Tamil Sign Language HTML, so this is a basic HTML CSS page that I created. So with a normal option of choosing and uploading images and videos, and so here's where the output from once the output is given, it will be sent to the this thing to the HTML. So here is where it will be sent and displayed. So this is the web application I built. So here you can choose the files. You can choose many number of images or video to upload. So for just testing purpose, I have got few pictures here. So I'll be using these pictures, and this is just basically which is I love you. So once you upload in the backend, it will be running, so it will take a bit of time to load the output. So here the output is loaded in Tamil. So this is how the system works for the Tamil Sign Language interpretation.